I order 74LS76 chip from robo.in site. The packaging is very good. The integrated circuit 74LS76 has two independent master slave.
So this is our master slave JK flip flop IC. See this data sheet. What this data sheet? This is the pin diagram of the JK flip flop. Inside this chip there are the two independent master slave JK flip flop. So if this chip is 76 only, then it is the positive edge triggered flip flop. What happens, JK input is loaded into the master while the clock is high and transferred to the slave on the high to low transition. For these devices, the J and K input must be stable while the clock is high. It means J and K must be stable, should not fluctuate. Truth table. Okay. When preset and clear are high, these are active low. So if they are high, then chip is ready to work. So with every clock pulse, we'll get the action. If both J and K are low, we'll get Q complement as a Q complement, Q as Q. So we'll not change anything. But when we make the J high and K low, we'll get Q high and Q complement low. And if we make the K high and J low, you'll get Q low and Q complement high. And we will make both the inputs J and K high, we will get the toggle condition. This is the truth table for 76. Master flip flop, and this is the slave. This is the slave and this is the master. This positive clock, a positive, then JK input. So whatever the JK input is loaded into the master while the clock is high, when clock is high, and transferred to the slave, and that input is transferred to this slave. This master output is 0, then Q complement will high. We'll see it practically. You can see this thing. You can see this is the clock for the first flip flop. This is the preset. This is clear, active low, so we make them high. And this is K and this is J for the first flip flop. 4 number pin is ground. Here's the 5 number is the positive pin. Then this is the second flip flop. This is the clock source for the second flip flop. The preset clear, active low, so making them high. This is the second flip flop J and second flip flop K. Take a look what happened. Q complement is high. Both J and K are low. So when we power on, this Q complement will get high. Now it is high. What exactly happening over here? K0, J0. So Q complement is high and Q is 0. So this AND gate is off, so 0 is here. This AND gate is off. This is the latch. See the latch. This output is giving input to this AND gate, and this output is giving input to this AND gate. So this is the latch circuit. Set reset latch. So what happening? So this is 0, and assume that this is also 0 because this input is 0. So what happened? Here you are getting the 0, 0, 0. sorry, you are getting 1 0 0. This is the NOR gate. So 1 is feeding into this. So 1 1 1. This is the AND gate. Here you are getting the 1. If that is the situation, 1 1 1. So 1 0 0. That 0 is feeding here. So I am getting 0 0 1 1 0 0. So this is latch 1 and 0. Now what happened next? Same thing is here. So 1 1 1. This is the NAND gate. So NAND gate logic is 1 1 1. All the inputs are high. So output is 0. And here 0 1 1. So you are getting 1 because one of the output is 0. So this is a NAND gate, exactly opposite to AND gate. So you are getting 1. This Q complement 1 and here is a Q complement Q complement 1. Okay. So Q is 0, Q complement is 1. That's it. Now let's move for the next. Now J is 1. This J is 1, K is 0. So this is the table. So Q is 1. Now Q is 1. And Q complement is 0. So now J, this is the J. So I am making the J is 1. And one clock is necessary. Q complement will not change until and unless I am giving a clock pulse. So I am giving the clock pulse. Now this will not change. You can see this will not change. Now this Q is 1. So why this Q is 1, we'll see it. If it is 0, then this will get a 0. See this latch. This is 1, this is 1, no matter. But this is 1 and this is 1. Now this is 1 1. This is 0. So 0 1 1 1 1 1 1 0. AND gate logic, NAND gate logic. So clock pulse is not at all important. It is not changing the state of J. Previously that Q was Q and Q complement was Q all the time. But here is the J, particularly J input giving the Q output high. So this is the Q and J high, Q high. That is the logic, stupid nonsense logic. Now see the next thing. Now K will make the K high and J 0. So first of all, we'll make J 0 and K high. So state will not change until and unless we are giving the clock pulse. As soon as I give the clock pulse, the state will change. So Q complement will become high and Q will be 0, giving the clock. See, now this will not change, not change at all. You can see that. Okay. Now the last thing, which is very important, so toggle. So what is the toggle? At one clock pulse, this Q complement will become high, and at with one clock pulse, this Q will become high. It will alternate with every clock pulse. It is the positive edge flip-flop, so it will toggle after each positive clock. So let's see what happened. Now we'll make both the J and K high. Now you can see the both J and K are high. So let's see what happened. Q, come on. This is what happened. Okay, it is sometimes the bounce is very much. So over this bounce I will add this small ceramic capacitor 0.1 microfarad. So you see this smooth operation. This is toggling. What you are seeing is the toggling. That's it. It's fantastic toggling. Now we are going to add two more in output to this circuit. So this another JK flip-flop will now show something important thing to you. It will not show unless and until you provide the clock source. So which clock source you have to provide? This one. This Q will be the clock source to this JK flip-flop. I think this LED is not working properly. No, it is working properly, but I connect it wrongly. Okay. So now see the toggling. Now I remove this complement, and now you will see this is the 3 binary 3, and this is the 1. This is 2, 1, 1, 0, 3. It is fast, so I'll make it slow. 0, 1, 2, 3, 0, 1, 2, 3. It is correct. 0, 0, 1, 2, 3,